Hello, this is Jeff Badge of the Grinding Doc, and today I'm going to talk about a company I visited in China a few years ago, and they had a question for me, and I used the concept of G ratio, something I teach in my classes, something people typically don't use. You can actually be pretty good at grinding and not use the concept of G ratio very much. It's still a very useful concept, but this is a company in China, and they had a question. And so I said, all right, let me do a basic G ratio calculation and we'll try to give you an answer. Okay. So I was sitting there after giving a seminar and the guys came up and said, hey, we got a bunch of questions for you. And so one of them said, okay, this is all through a translator because my Chinese is a little rusty. And they said, hey, we're doing ID grinding of very, very small ID little bores, not even bore, little ID things. And smaller than that, but I just happen to have this lying around. So smaller than that and a smaller wheel than that. And they said, okay, we've got a chunk of steel. Maybe it was more like that size. So we got a chunk of steel and we're putting a little hole in there. And each chunk has 20 holes. And last year we produced 20 million chunks. So 20 million by 20, 400 million holes. So last year we made 400 million holes and we were grinding them. And I tell you, man, we were grinding and we were just eating through our wheels and we were consuming a huge amount of wheel. And we want to know why. What can we do differently? And I said, okay, our first question is, are you sure you're consuming a hell of a lot of wheel? Or maybe that's just the nature of the beast because the circumference of this wheel, because of small diameter, is not very big. So let's take it one step at a time and let's find out, okay, how much wheel wear are you actually getting? What's the circumference of your wheel? We can use that if we know the concept of pi. What is your bore diameter? What's the diameter of this part? How wide is it? Are you doing any oscillation? And then how much stock do you remove? Are you removing 25 microns or a thou? Are you removing a millimeter or 40 thou? How much are you taking off of there? Okay. And so I got with the guy, the engineer, and they said, okay, well, here's the size of the part, the bore, the ID. Here's how deep it is. And in one situation, we're just going in and we're doing a straight plunge. That makes things difficult, actually, but we're going to do a straight plunge, and then we come out. We maybe do a little bit of oscillation, maybe we don't, but we just do a straight plunge, and we have to dress the wheel 25 microns every part. I'm just making these numbers up because I don't remember what they are, but you get the idea. And I said, okay, you're dressing 25 microns apart. What is your wear per part? And they said, well, we don't know. We just dress 25 microns. And I said, okay, let's assume your wear is half of that because you're just doing it to be safe. So you're wearing 12 and a half microns or half a thou per part. And the part was in stainless steel. I remember that. So they have a stainless steel part, heated up or hardened to whatever rock they had. And you're doing your little holes and you're dressing every single part, every single hole, whatever it was. And I said, so let's do a calculation. Your diameter is whatever it is. Let's take the circumference. You're removing, let's say 50 microns of stock. You're removing 25 microns, 25 millimeters this way. We got a wheel that's smaller than our bore, hopefully. And it is wearing away 12 microns because that's what we estimated it at. And our bore is about the same size as our wheel is about the same size as the bore. And we know the circumference of the wheel because we know the diameter of the wheel. And I said, okay, so let's do the calculation of the G ratio. And the G ratio you're getting is the volume of material that you grind away divided by the volume of wheel that you lose in the process. And I said, hey, these are all just kind of ballpark numbers just to see where you're at, but you're getting a G ratio of 27. You're grinding hardened stainless steel with an aluminum oxide wheel with a finer grit, and you're getting a G ratio of 27. I said, stop your bitching. You're doing fine. Stop whining. Stop being a baby. Because when I visit customers overseas, it's always good to be professional and culturally sensitive that way. And I said, stop your bitching, man. You're doing okay. That's just the nature of the beast. Based on the size of the bore, the size of the wheel, you're getting a G ratio of 27. And I've got in my head a kind of a catalog of what a reasonable G ratio would be. And that would be a reasonable G ratio for aluminum oxide. Now, if you're not happy with that, we can get it up. We can increase from 27 to maybe 40. And we would do that by a harder grade wheel. We would do that by a smaller grit penetration depth. But that's it. We're going to get it from 27 to 40 or 27 to 50. But we're not going to get it from 27 to 500. Said, so I can work with you on that. I can tell you what to do. Show me your wheel specification, and we'll see if that's even possible, depending on what you're using now. Show me your grit type. If you're using a white alumina grit, which is friable, you might want to switch to brown, which is tough. That could be part of the solution too. But the solution is going to get us from dressing every 5 holes to every 8 holes or every 10 holes or whatever it is. But it's not going to get us from dressing every 5 holes to every 50 hole. So we used G ratio to put us in the ballpark to see, okay, how are we doing and were we being reasonable? Okay. Then I said, hey, if you guys want to take it to the next level, and you want to wear less, then you could switch to a CBN wheel. Got to be careful. It depends on what your coolant is. You could switch to a dressable CBN and you'll do better. You could switch to a plated CBN and maybe do better depending on how rough of a surface finish you can tolerate and depending on what your coolant is, because you don't want to use plated CBN in a water-based coolant. People try it and they waste the time. They reinvent the wheel. So we can chat about that. But we use the concept of G ratio to kind of give us a starting point to figure out, okay, are we in the ballpark of where we should be? Now, where do we want to redirect our energies? Or where do we want to direct our energies to helping our friends in China make more holes, grind more holes before they have to dress their wheel? Okay. Then there are other issues I won't get into here, like if it's a through hole, we could get a long wheel and do oscillation, and that would give us more abrasive to play with. If it's not a through hole, then we're stuck. We're just stuck with whatever we have. So there are those considerations too. But the main point of this is to talk about G ratio and how you use it to analyze the process and then improve it. This is Jeff Badge of the Grinding Doc, talking about grinding and the stuff that I teach in my grinding courses, stuff that's given in the Book of Grinding.